Okay, hey y'all. We are actually going to do some long division right now with polynomials. Let's go ahead and open up our thing. We need a new one, which is going to be right here. Is it going to save that? It doesn't matter, but kind of matters. Okay, so we are going to do some long division right now. I'd like to start this with a recall. Let's go ahead and recall. When I say long division, if you think back to grade school, this is something that we were taught to do our division. Let's say we have 4,097, and we were to divide it by 4. Okay, so just to work through this quickly, we have our dividend, which is 4097, our divisor, which is 4. You're going to take the first number in your dividend, which is 4, and we're going to see what happens if I do that number divided by my divisor. So 4 divided by 4. Or what you could think of is your divisor, how many times could it go into that first digit, right? I would usually just do 4 divided by 4 is going to give me 1. Here you do the multiplication. 4 times 4 is 4. And then if you notice, that's a positive 4, but the step here is to actually subtract. If you do 4 minus 4, additive inverses, you get 0. Bring down, you get 0. 4 goes into 0, 0 times, which would be 0. 0 minus 0 is 0. Bring down, my 9. Now let's look. 9 divided by 4. Well, that goes in 2-ish times. I'm more concerned about how many times will it equally go into it. And it will go into 9 a number of 2 times and only 2 times, because 4 times 2 is 8. And that is actually going to be the only amount of times it can go in without going over, right? And so what I would do here, that was a positive 8, but of course I'm going to subtract it, and I would get 9 minus 8 is going to be 1. What you do is you bring down your 17. Then we look to see how many times can 4 go into 17. Technically what we're doing here is 17 divided by 4. I know that equally it will go into it 4 times, because 4 times 4 is 16. What I end up getting here whenever I do my subtraction is going to be 1. This is my remainder, and the proper way to write our answer would be our quotient. The quotient is going to be the answer to a division problem, and then we're going to put our remainder over our divisor. So this answer would be 1,024 1/4. That's saying how many times 4 can equally, or how many times, that can 4 go into 4,097, or more simply put, 4,097 divided by 4 equals 1,024 1/4. Okay, so again, quick recall. Now, what we're going to do is actually look at polynomials, and we're going to do a very similar process. Okay, so doing that, say we were asked, let me do long division with polynomials. Okay, and a polynomial is going to be anything that has more than one term. So like the number 2, that's not a polynomial, but if we have, say, x plus 2, that's 2 terms that can't be combined because they're not like terms, therefore it would qualify as being a polynomial. Say we're given a problem and it tells me to do x squared plus 8x. And then I have I don't really like it when it does that. I think I'm going to change that. I think it was that one. Okay, x squared plus 8x. And we have plus 12. We've got our division symbol because these problems can be written in two different ways. And then we're going to divide that by x plus 2. Okay, so I really wanted this to get smaller, but it's not gonna. So I need to move up, y'all. Okay, so what we would do here is we're actually going to rewrite it in the same way that we perform long division in grade school. You're going to take that leading polynomial, which was x squared. You're going to add to it an 8x, add to it a 12. Then we're literally going to divide it by our second polynomial, which was x plus 2. Okay, so it should look similar. Now the steps that you follow are slightly different just because we aren't dealing with just numbers. So our very first step is to look at the leading term of our dividend, which is an x squared. You're going to look at your x squared and you're going to divide it by your x, okay? And then that quotient's actually going to be placed here because we want to make sure we keep like terms together. So what we do is x squared divided by x. Y'all, this is a lot of exponent rules, okay? It really is. When you divide variables, what you do is you keep and you subtract. So x squared divided by x, what you do is you keep your variable and you subtract your exponent. 2 minus 1 is 1. It is written above 8x because those are like terms. Now what you do is you do multiplication with the quotient that we just found multiplied by both of those. So if you do, and you do it individually, it's basically distribution. If you do x times x, we get keep and add. If you do x times 2, we get 2x. Both of those are positive, so our product is positive. And then, just like we did in the recall, once I did 4 times 1 and I got 4, do you notice how what I did was I subtracted that 4 from that first term in the dividend because 4 minus 4 equaled 0, right? We actually need that to happen. So what we would do here is we are actually going to subtract this x squared positive 2x. So in your notes, what you could do is just draw a minus sign, just do it thick, use a different color. You could put it in parentheses and distribute a negative through there. Then you just kind of have a bunch of different signs. So I would just change the signs, write that in there. Now, if we do that subtraction, when you subtract variables, it has to have the same exponent and the same variable, which is why I made sure to line things up in a specific way so that they could be combined. If you do x squared and then a minus x squared, those would be considered additive inverses, and I would get 0, which is great because that's what I have to get. That's what I need to get. Then if you look at your next terms, I've got an x to the, I'm sorry, I've got an x with my 8. So 8x, my mail just got here. Sorry, that was the noise you heard. And then if you look right here, I'm subtracting from that a 2x. So signs are different. You would subtract, keep the sign of the larger, keep your variable, keep your exponent, right? Now, the step here that we perform is to bring down whatever you have here, which is a positive 12. Now what we do is we're going to take, where is it? This one. We're going to take this first term and we're going to divide it by this first term. The quotient of that is going to go right here. So if I do 6x divided by 6, I get 6. Signs are the same, so it's a positive 6. And then what I do is the multiplication between this term and that binomial. Of course, multiplying them each individually. So if you do 6 times x, you get 6x. Then if you do 6 times 2, you get 12. Signs are the same, so it's positive. And then similar to what we did right above us, whenever I change the signs, that's what you do here as well. Draw your line. If you look at 6x minus 6x, those are additive inverses. They go to 0. If you look at a positive 12 and a negative 12, those are also additive inverses. They go to 0. So, I mean, technically, I just went to 0, right? Now, as far as like homework is concerned, what you do the same way whenever we recalled, my remainder of 1 went over my divisor of 4, and I had a fraction of 1 over 4. You will also put these in that same form. Even if your remainder is 0, it would look like this. So it was, we asked you to solve x squared plus 8x plus 12 divided by x plus 2. So the way you would write your problem is you do your quotient first, and then you add to it your remainder over your divisor. Okay? So quotient first would be x plus 6 plus remainder over divisor. That is your final answer to dividing those polynomials. Okay. So I'm actually going to stop this video because I'd like to do 2 other examples, and I think the shorter the videos are, the little bit easier they are to upload. So I'll see you in a little bit. If you have questions, make sure y'all ask.